Yo, what's up, geometry students? Mr. Mester, back at you. Finding surface area. Now, I'm gonna kind of not do exactly what we're doing here. I'm gonna kind of get the idea of it, but it's just hard to do it nicely. Oh, we're also missing something. All right, cool. Let's call that 2 centimeters. You weren't given the height, so you need to come up with it. Maybe it's an H. Maybe this is H. What I tried to tell my students in class is to find the surface area. It's almost like we take the three-dimensional objects and we pull off the pieces and we put them flat on our paper. We add up all of the areas. So the key is for you to understand what all of the pieces areas are. And you don't have to draw the net. The net might be helpful, but if you could just understand, I got two of these h by 10s whose area is 10h. So I got two of these 10h's. So I got two 10h's, I got 20h's. And then I got two of these 15 by h's. If this is h, so I got two of these longer 15 by h's. It's so tough to like draw the net perfectly, so I'm not going to do it. Two of these 15 by h's, so that's 15 h's. So those are going to be a total of 30 h's. So then I got 20 h's, I got 30 h's. And then what's left? The top and the bottom. Well, the top is a 10 by 15, and I got two of those 10 by 15s. The key to this entire unit is don't think things are just like super easy. We'll see how two of these 150s. And this is fine. If you want to simplify it, it's 20 H's plus 30 H's with there's 50 of these H's plus 300, which is good. Let's do the next one, the rectangular prism. I got to zoom in on this. All right. Triangular prism. Let's go into this one. All right. So I got two of these triangles that are base of 12, height of 8. So half the base is 6. Two 6 by 8s is 2/48. So I got 2/48 of those. Then I have these here. Two of those. Now it looks like they're hooking you up by telling you that this is 10. And they're correct. That's because if we split this in half, this would be 6. And if you use the Pythagorean theorem, you'd say 6 squared plus 8 squared is 10 squared. It's a little soft that we gave you the fact that this is 10. To be honest, I would just like not have that included and have you find it. Remember, we could always use our previous knowledge to help us with this current stuff. So here's two rectangles that are 10 by 19. So that's 190. So I have 380. So I got two 48s. I got 380. And then I got a 12 by 19 on the bottom. So the bottom is a 12 by 19. Whatever that is. And then you like have a calculator and you add them all up. And I don't have a calculator, so I don't care. There's your answer. It's not an arithmetic class, it's a geometry class. Doesn't mean you don't know how. All right, well, there you go. Doesn't mean you should know how to do the arithmetic. All right, we got a square pyramid. So we got a square on the bottom, which is a 12 by 12, taking the pieces apart and putting them flat. So This is one of the first things that I remembered in elementary school was that 12 times 12 is 144. Okay, now I got four of these triangles, and these triangles have a base of 12, but it looks like the diagonal is 10. Well, I mean, that last problem is probably going to help you. This is 6, this is 8, this is 10. So I have four of these 1/2 base times height, or four of these 48s. Whatever this is, that's the answer. I don't care. Use your calculator. Feel good about yourself. If you don't have a calculator, don't waste your time. Student draws a net for a solid and then calculates the surface area. What 3D solid can be assembled from this net? It looks like it's a triangular prism. Student made some mistakes in the area calculations. Identify the mistakes. Yeah, these are sixes, half of a base times height. That's 12. That's 16. That's 20. Cool. Whatever that is. All right, well, each of these are 1. So this side is 6, which means the other side is 6. The bottom is going to be a 3x2, and the side is going to be a 3x2. All right, so this is fun. So let's take off the pieces. We have this, 2 of these, which are 6 each. So we got 2 6s. Then we got the bottom, which is a 2x3, which is 6 each. 1, 2, 3, 4, 5, 6, right? We have that. We have the back of it. So I have 2 of those flat. But then I actually have the side, which is also a 6. So I have 3 of these. But then I have the top, which is also another 6. Turns out our surface area would be the same of a solid rectangular prism. That is like a 2x3 by 3. 2x3 by 3. So we really have 4, 5, 6, 6 sixes, which is 36. How would the surface area change if the top 2 cubes are removed? Well, we wouldn't have the sides, but we'd keep the top. We wouldn't lose the bottom, so we would lose just like the around the outsides. I'm thinking we're gonna be minus 1, 2, 3, 4, 5, 6. It's just like something to try and think about. This is all 10 when I roll it out. This is a 5. This is a 5. This is why I like the nets are so tough. These are 4s. This is a 5. This is why this I don't love doing this. I kind of want to just be like, I got 2 5x4s. I got 2 4x10s. So the two 5x4s are the bottom and the top. The two 4x10s are the side and the side. And then I got two 5x10s. And honestly, that's what I'm doing. So I got two 20s, which is 40. I got two 40s, which is 80. I got two 50s, which is 100. So I got 80 and 40, which is 120. I got 220. Cool. Same thing here. Like, it's kind of tough to see, but maybe you can easier this. This is a 10, this is a 4. These are all 13. That's kind of obvious. Now, what would be the areas of these triangles whose side lengths are all 13? Well, you'd have to split them in half, and you would have to use the Pythagorean theorem, where this is 5, and you do 5 squared plus b squared equals 13 squared. You'd find that b is 12. Do 2 squared plus b squared equals 13 squared. You get b squared equals 169, 165. B is root 165. Anyways, you'd have a 4x10. You'd have 2 half your base times your heights. And then you'd have 2 half of your base, half of your base 5. This was 12 times the height 12. And then 2 half the base was 2. And then the height was 165. What 3D solid can be assembled from this net? A pyramid. Talk about the volume periods in the next class. If each square of the grid is 1 square unit, what is the surface area of the figure? I mean, this is 1, 2, 3, 4. Okay, so I got a 16. And then I got 1, 2, 3, 4, 5. It looks like this is 5. All of these are 5. So I got 4, half of my base times the height. So I got 40, 56. Cool. Here are two 3D solids. For each statement below, decide if this statement describes figure A, B, neither, or both. Yeah, can I just say this? There should be a cylinder on this, but whatever. My class, you'll see cylinders on your entrance ticket, but we'll practice it. So here's number 7. Cylinder, radius, 4, height, 6. What is the surface area? All right, figure out that one. We'll go to this. This figure has triangular faces. I mean, both A and B do. There are more vertices than edges in this figure. 1, 2, 3, 4 vertices. 6 edges. 1, 2, 3, 4, 5, 6. 1, 2. There's some graph theory talking about vertices and edges of a 3-dimensional shape, and the answer is like you can't have. See, I mean, 6. You have to have more edges than vertices. I don't. That's a bad question. I mean, that's fine. That's fine. Okay, surface area. We got two circles. We got two of these circles whose radius is 4. So I got 2 times pi r squared. 2 times 16 pi, 32 pi. And then we got one of these rectangles, which is the middle, unfolded. We have this height, which is 6, it stays 6. What is this length? Well, when we unfold the cylinder, we realize that the perimeter around the circle on the top becomes the length of the rectangle. This is a 2 times a pi times an r. That's 8 pi times 6. So that's 48 pi. And we get 90 pi, 80 pi, 80 pi. Okay. Squared units. Yeah, expect on my students' entrance ticket a lot more having to find stuff. I'm throwing 30, 60, 90 triangles at you. I'm throwing 45, 45, 90 triangles at you. I'm going to throw some cylinders at you. We're going to have some fun. Peace.